So we're in the OpenStax Statistics Chapter 6 Excel file. So we're working through an example that has to do with final exam scores. So as a reminder, you can always access the OpenStax textbook for free. If you look in the description of this video, there's a link. And then you can get a free copy of the Excel workbook if you go to my website, divideandconquermath.com, and then go to the OpenStax Statistics section. Again, you can look in the description for a link to that. So I'm in the third tab. It says X example final scores. So there's a few things that we need to talk about in this particular tab. This has a lot of very important information. So we have been given the information that we have a mean of 63 and a standard deviation of 5, and we're asked to compute a few different probabilities. So the first one is filled out for you just so that you can kind of see how the formulas work. So we're asked to find the probability that a randomly selected student scored more than 65 on the exam. So it's very important in statistics that you get used to using the notation of statistics. So get in the habit, whether you're writing things down or doing things in Excel, of labeling what it is that you're finding. So as a probability statement, this idea of the probability that a randomly selected student scored more than 65, that's going to be P of X is greater than 65. Now, the other thing you're going to want to do right away is you're going to want to draw a normal distribution that goes along with your situation. And so the normal distribution that you draw will depend on what type of distribution you're choosing. So I have two different diagrams here. So for the first one, this is just the normal distribution. And so the normal distribution, remember, is always going to be centered at your mean. So my mean was 63, so you can see how it's centered here at 63. So where does 65 fall in relation to 63? It's somewhere over here. Now your scale doesn't have to be perfect. You just need something to kind of make a gauge for yourself. And so then this idea of the probability that X is greater than 65, here's 65, what's greater than that? That's this blue area in here. So this is ultimately like the area of the normal curve that we're trying to find. So you can either use the normal distribution or you could use the standard normal distribution. So if you want to use the standard normal distribution, that would be over here. Standard normal distribution is always centered at 0, but the standard normal distribution is going to require that you know the z-score of 65. So we'll come back to this idea in a second. Let's finish up talking about this and then we can pivot to the standard normal distribution. Okay, so for the normal distribution calculation, I've already filled in the formula here just so you can kind of track how everything works. And I have some hints up here of how these formulas work. You will use these formulas quite a bit in statistics. So maybe you want to also write these down as separate notes or make yourself like just a little cheat sheet that you can refer to of commonly used Excel files, whatever you want to do. But these are kind of the key prompts that you need to know. So we are just using the normal distribution calculation right now for this. So that formula is going to be NORM.DIST. And then here are the prompts. So if I type this in, NORM.DIST, if I open that, you can see here are the different prompts that come up. And basically what this box is doing is it's just giving you a little bit more ideas of like what exactly we're looking for. So you're going to input your X data values. So that's whatever you're doing your probability around. And then you put in the mean, the standard deviation, and then you always end, this will ask for whether you want this to be a cumulative sum, so you always just write true for this. So you don't have to worry about this, just write true. Okay, so the thing to know about this is that this calculation defaults to always calculating to the left. So if you look at what I've done here for 65, so you'll notice I actually have 1 minus all of this. So I'm going to get rid of this 1 minus up here in the formula bar for a moment, just so you can kind of see what happens. So if I just investigate my NORM.DIST function, so look how I've set it up. I put in 65 because that's what our probability is around. And then notice how in my formula, I didn't write 63. I referenced the cell that has the 63 mean. And then I also reference B3, that's the cell that has the standard deviation. So I like to just reference the cells. That's how I operate, but you can do you, and then I always end up with true. Okay, so if I hit enter on this and I just leave it as is, so I don't have it as 1 minus, this returns 0.6555 or 0.6554. Okay, that is the amount of area that we're talking about. So this can go up to 1, right? So if I'm looking at this normal distribution here, that 0.655, does that look like the amount of area contained in the blue? It does not, right? So your mean perfectly divides your normal curve into 50-50. So this 0.655, since it's always calculating to the left, I think you can pretty easily visualize that all this white space in here, this is about 65% of the area. That makes sense intuitively. And again, it's because these calculations just always calculate to the left. So if you want to get the right part of this, then you just have to use subtraction. So that's why we do 1 minus that formula. And this will give me this 0.3556, or 0.3446, sorry, I can't talk. And yeah, that intuitively feels right for what amount of area is shaded in here. So when you do these problems, you want to always get in the habit of drawing the normal curve with the mean and whatever data point you're interested in, because this is going to give you kind of that sanity check of whether this number makes sense or not. If you don't have the picture, you are really putting yourself in a risky situation of finding the wrong number and having no intuition about whether or not that number makes sense or not, okay? Now, remember that the normal distribution and the standard normal distribution, they return the same amount of area, okay? So what if instead of using the normal distribution, I wanted to switch this to the standard normal distribution? I can do that, but we just have to keep in mind what the differences are. So on the normal distribution, this axis here, these are x's. But for the standard normal distribution, this axis here, these are z-scores. And you can even see that there's a z here, right, as like a hint. So for me to be able to draw this situation using the standard normal distribution, I need to have now my normal curve centered at 0, because the standard normal distribution is always centered at 0. And then I need the z-score of 65. So notice here I have step 1, find the z-score. And if I click on the formula bar, you can see that I've set everything up. 65 minus, there's my mean, divided by my standard deviation. So I get a z-score of 0.4. So if this is 0, where is 0.4 in relation to 0? It's somewhere over here, okay? And so what is this area then to the right of that? So with these lines, it's going to end up being the same thing. So notice how this particular calculation works. So we have 1 minus, because that's going to get us to the right, so this part here. And then I have NORM.S.DIST, but the formula for this, so I have the hint right here, NORM.S.DIST, all you have to do is input the z-score and then true. So you'll see that in here, in the formula bar, I reference that z-score that we just calculated and then true. And I have 1 minus that again to get us to the right. And so we get the exact same answer. So which one should you use? You should be comfortable with using both of these and understanding how to flip between the two, because it's going to depend on the question as to which one you want to use. So you really want to get your brain used to understanding how to flip between these two when you're first learning this, because it's going to give you a lot more freedom as we move down the class. So now I have another one here for you. I want you to do the exact same thing where I want you to draw everything out and I want you to do all the calculations on your own. You have all the hints up above. So I would recommend that you pause the video here, find the probability that a randomly selected student scored less than 85. So first calculate this via the normal distribution and then via the standard normal distribution. And you should also draw some curves in your notes just to model this situation. So give that a try, hit play when you're ready. Okay, so first of all, we need to write the probability statement. So the probability that a randomly selected student scored less than 85, that's going to be P is X is less than 85. Now, I know a lot of times, you know, especially when you're watching these videos on your own, there's kind of that that desire to scoff, oh, I'm not going to do that. That's just extra annoying math stuff. I'm going to tell you that you've really got to get in the habit of labeling things well in statistics. Statistics is a lot about organization. So don't scoff at it. Get in good habits from the start, or otherwise I see that kind of hurts a lot of students later on. Okay, so remember, we do want to draw a curve before we go any further in this. So I have drawn a curve over here. So let's see, maybe I'll bring this curve up here. Oops, that's not going to work. Let's see if I can do this. I think I can copy, paste. There we go. Okay, so I've got my curve here. So I'm trying to find this area. This is going to be a pretty large amount of area, right? Because 65 was like somewhere over here. So 85 is really going to be somewhere on the tail end. And if you think about it, where 85 is, so a standard deviation in this situation is, so this is a standard deviation of 5. So 85, that is, let's see, 63 plus 15, that is more than 3 standard deviations away from the mean, okay? So just something to kind of think about, like in terms of how much area this is going to end up being. Okay, so anyways, let's go ahead and fill this in now. So I've got NORM.DIST, so I'm going to use 85 for my x, and then I like to refer to my mean and my standard deviation as cell references, and then I can type in true. So there is my formula. Okay, and I'll hit enter. And so this calculates to the left, and in this case, this is appropriate. And like I said, this should be quite a bit of area because 85 is more than 3 standard deviations away from the mean. So this is going to encompass most of the area, so 0.999995, that sounds appropriate. Okay, so let's go the other way with this now. Let's find the z-score. So I'm going to take 85 minus 63. Notice how I have used parentheses here. And then I need to divide this by the standard deviation, so it's divided by 5. So my z-score is 4.4. So this is telling us now, remember what a z-score actually means? This is telling us exactly how many standard deviations away from the mean we are. So 4.4 standard deviations away from the mean. So that's huge. So when you have a z-score, that is really telling you a lot about the area of the curve. And so again, if I'm talking about to the left of something that is so many standard deviations away from the mean, like eventually, hopefully you build an intuition that that's going to encompass most of the area. So now let's go ahead and do NORM.S.DIST. So in this case, I refer to the z-score and then true, and bada bing, bada boom, we get the exact same number for both. Now, if I wanted to redraw this with the standard normal distribution, I would just change my mean now to be 0. And instead of this being 85, I would change this to the z-score of 4.4. So tomato, tomato. Okay, and so that's it for this tab.